Hello, my name is Dae-Hyeon Kang, and I'm from the Soft Computing Lab. Today, I will be presenting a paper called Data Mining for Item Recommendation in MOBA Games by Vladimir et al. It was published in Rexis in 2019. These are the contents. First, I'll talk about the brief introduction as to why this paper is relevant and the motivation behind the paper. Secondly, I'll give a brief overview of League of Legends and the challenges that other related works face. Then I'll split the methodology into four sections: dataset and preprocessing, association rules mining, classifier, and ranking. Finally, I'll finish off with the results and conclusion of the paper. The motivation for this paper mostly stems from the popularity of esports, which recent studies showed that an estimated 335 million spectators watched esports in 2018, generating a revenue of more than $900 million, and mobile games being the biggest genre played. Several AI studies related to mobile games have been carried out. For instance, intelligent agents, prediction of match outcomes, and also recommender systems. Here, the authors wanted to focus on recommender systems specifically for item recommendations. The reason being is that League has over 200 items, and as more and more items are introduced and taken out, it can be overbearing to new players who want to try out the game. To solve this problem, they want to create a context-based item recommendation system that will help attract and retain new players. So what is League of Legends? League, or LOL for short, is comprised of two teams of five. The objective of the game is to destroy the enemy base before the enemy destroys yours. Each champion has their own exclusive skills and abilities that scale with the items you buy from the shop using gold. Gold is given by taking objectives like dragons or turrets, as well as killing things like minions or enemy champions. With so many things to consider, what items to take are always similar but different for every game. So the authors decided to take the context of enemy champions and the champion the person decided to play for deciding which items to build. This is the basic framework for the mythology. The first pre They first pre-process the given dataset to fit their research. Then they analyze the data using two different methods, which are association rules mining and classification. Afterwards, they sort the data to choose the best item set and output the recommendation list. I will talk about each step in more depth, starting with how they pre-process the data. The dataset comprises of 184,070 ranked matches from EU and NA. It contains champions that were used, items purchased, and resulting stats for each match. The authors then modified the data to be a transactional structure, where each instance includes the identifiers of a selected champion during a match, the items used, and the enemies involved. Then they filtered the data to only winning matches of Season 7 because each season has different metas which change the items to build, and losing matches aren't needed because those items are correlated to losses. This also means that any champions that came after Season 7 would be excluded. Finally, they only used items that are finished, unlike transitional items that are used to create finished items, as well as wards and consumables. This leads to the final dataset containing 136 champions, 93 items, 631,590 instances for training, and 70,405 instances for testing. Now, the first method they used is called association rules mining. The basics for association rules mining is to create a number of rules to determine if A, then B. For example, if 100 customers came to the store to buy bread, then also bought butter as well, then we can say if they buy bread, then they also buy butter. So with that, there are two algorithms that the authors use to determine which is a priori and eclat. I won't be going over these methods here as they are functions to organize the relationship between items. So then, the algorithm generates rule with the form x to y, where y is an enemy champion and x is the subset of items. D is the transactional data of a picked champion composed of the enemy team and the items used. On the one hand, support is defined as the perceptual frequency of observations of the same item in all the transactions. On the other hand, confidence is defined as the probability of y given x. The second method they used were using classifiers. They applied a supervised approach for multi-label classification to obtain a mapping between feature space, which are champions, and label space, which are items. On the one hand, the input, which represents a match played, was coded with 1 hot, where the selected champion was represented with 1, the enemies with -1, and the rest with 0. On the other hand, the output presents the items used with 1 and 0 for the others. They evaluated 3 types of classifiers, which are the decision tree, logistic regression, and artificial neural network. After they get the results, they rank the outputs. For association rules mining, they generate several item sets and sort them by their confidence level, highest to lowest. If the highest confidence item set is over 80%, they will choose that as the recommended item list. If not, then the item set is merged with the next highest item set until the confidence level threshold is met. As for the classifier, they pick the most probable item for the context at the beginning, and so on until they have n number of items in the item set. Here are the results. First, if you look at the table on the left, there are 5 different scores to look at. MMP, which is the mean average precision, evaluates relevant items from 1 to k. And the MRR, or mean reciprocal rank, evaluates the rank of the first correct item. As you can see, out of the 5 methods that the paper introduced, AAN does the best for every number of items in the item set, which they used for one item in item set, 3 items in an item set, and 6 items in an item set. On the right graph, you will see that there are 2 more methods compared with the original 5, which is the most popular method for item recommendation, using only champion picked and just random recommendation. From these results, you can see that items recommendation is truly contextual based on enemy champions as well as items purchased, since the most popular and the random methods are very low compared to the methods that the authors used that had context of enemy champions as well as the items bought. In conclusion, the authors presented a simple framework for the recommendation system for League of Legends. They emphasized that more work is needed to include transitional items as well as consumables and not just finished items. They also plan to add more context info, just as allied teams, item characteristics, and character rules in the future. From playing League recently, I believe this has already been implemented, as I've seen them recommend consumables and transitional items at the start of the game, as well as certain items that are only fit for roles. For example, if I pick the support role, they will give me support items more than they would give for a mid laner. And that is it. Thank you.